Hello everyone, our project is the Unmanned Aircraft System Traffic Management Services for Unmanned Aerial System Registration and Flight Approvals from Honeywell. For team members, we have me, you, Caitlin, Kevin, Denise, and Nathan. Project description and motivation. So the Unmanned Aerial System, or UAS, also commonly known as drones, are rapidly becoming a popular tool in various industries, including agriculture, inspection, and delivery. However, managing UAS operations manually can be time-consuming, complex, and prone to human error. Our project seeks to address these issues by automating the management of low-altitude UAS operations. Our project supports the registration of unmanned aerial vehicles, also known as UAVs, and pilots, creates and validates flight plans, grants approvals based on real-time air traffic and restriction data. This enhances the safety and efficiency of UAS operation while ensuring compliance with airspace regulation. Our primary motivation behind this project is to address the challenges faced by UAV operators and payers responsible for the safety and security of their drone operation. Project goal. So our project aims to increase the efficiency, safety, and security of UAS operations while improving airspace utilization. As the use of UAS continues to grow in various industries, it's important to address the issues to ensure the safety and efficiency of integration of UAS into public airspace. Our project has three primary goals. The first goal is to increase the efficiency of UAS operations by automating the registration and approval process, freeing up resources for other critical tasks. The second goal is to enhance the safety and security of UAS operations by using real-time air traffic and restrictions data to grant approvals, reducing the risk of mid-air collisions. Finally, our third goal is to improve the airspace utilization by deconflicting flight plans and optimizing UAS operations. These goals align with the growing demand of the UAS industry and the need for safe and secure UAS operations in public airspace. Customer discovery process. So understanding the needs and pain points of our target customers is crucial for developing a project that meets their requirements. Our customer discovery process involves identifying our target customers, which include UAV operators in industries such as agriculture, inspection, and delivery, and payers responsible for the safety and security of their drone operations, including government organizations and private companies. We then try to understand their pain points, such as manually process of creating flight plans, obtaining approvals, and stay up to date on air traffic. From there, we identify their needs, which include real-time monitoring of UAV operations to ensure the safe and efficient operations, and validation and deconfliction of flight plans to reduce the risk of collisions. These insights were critical to developing a project that meets the needs of our target customers. Next up, we have development of requirement. Developing a project that meets the needs of our target customer requires a clear set of requirements. Our development of requirements involve identifying the features and functionalities required to achieve our project goal. Our development requirements also involve identifying these also include developing a UI system that aids safe and secure low-altitude unmanned aerial system operations, providing the ability to create and validate flight plans, offering automatic flight approvals based on real-time air traffic and weather data, providing real-time monitoring of UAV operations, including flight plans, paths, safety alerts, and managing storing data related to UAV operations, including flight plans, flight logs, and safety data. These requirements will enable us to achieve our project goals and meet the project needs.
For the front end, HTML and CSS were used for the layout of the user interface. Then JavaScript was used for the functionality of buttons and text boxes to help complete certain tasks. For the back end, Python was used for more in-depth functionality for those buttons, text boxes, and other user interactive elements. The main page of the website displays a map that shows the user's current location. Folium and GOP was used for this function. To save users' accounts, the information in flights, DynamoDB was used to implement a database. AWS was used for the backend as well. On every single page, except the logout and create account page, there's going to be a general layout. That layout includes a notification button that shows the users important messages or important updates and lists interactive icons that allow the user to be directed to another page. The summary will display the user's geofence location on the GPS and display the weather information. The weather information is there so that it will prepare the user for their future and current flight plans. After a user creates an account, they can always update their information, such as their first name, last name, email, and job role whenever they need. In addition, if a user runs into a problem with their account or flight plan or have any questions, they can go to the help page to find a solution to what they are looking for. However, if that does not satisfy the user, then they can submit a form with their information and message on the Contact Us page. Additionally, when the user no longer wants to keep their account, they can delete it on the settings page. The setting page allows the user to change from admin to user account and vice versa as well. The aircraft page displays the user's list of registered aircraft. All the flight plans will be displayed on the flights page. If a flight is approved, then this page will validate the flight plans that the user creates. It also includes a list of the type of aircraft, date of flight, and altitude of.
I'm Segovia, and I'll be continuing the presentation. For our database, we will be using DynamoDB. It's a service that is integrated into AWS. It's also a NoSQL database that uses key value storage instead. Since it's part of a service of AWS, this means it's easily integrated within our project. This allows us to also make many tables and easily manage these tables. We will also be using a Lambda function and API gateway. The benefit to this is that we will be able to locally test these functions without needing to have an increased cost for each test we have of the function. Once we get these functions fully tested, fully ready, we can easily deploy it using serverless as well. Once we deploy the Lambda functions, it integrates easily into the API gateway, and it allowed us to easily create a REST API. For our libraries in Python, for the backend, we used Folium and GeoPy. Folium is an open source Python library to create visual maps and allows us to integrate various data to it. The big thing about Folium is that they want you to make maps using data, and these maps are for the whole entire globe. So you can plot any map anywhere in the world. And to do this, we use GeoPy. GeoPy creates coordinates out of directions. For example, if we type in the ASU coordinate or directions, it will give us a coordinate pair that allows us to plug in the latitude and the longitude into Folium. And as you see in the screenshot on the bottom, that is a radius of a arbitrary radius with the points being random spots in the ASU vicinity. GeoPy also allows us to plot lines that will be our flight paths. For example, that red line between two dots is potential flight pathing. We can connect multiple lines together, allowing us to make the optimum flight paths. Since we will be having multiple drones in our projects, being able to create many instances of latitude and longitude to create these flight paths allows us to be versatile with our flight pathing. A great thing about Folium is it allows us to create geofences, and that's what that arbitrary radius that you see there in the bottom right, that is a geofence of what the drones or where the drones are able to fly. For weather information, we will be using the Open Weather API. It's one of the most popular weather APIs out there, and it has a very versatile free user experience. The reason for this is the amount of data they are able to give you. We can have information from temperature, humidity, wind speeds, and more, but those are the major components towards our projects. And since it's free, it's also amazing. Now, for flight pathing, we are still in work in progress. There's a lot of work that needs to be done in flight pathing, but here's a high-level overview of what we will be implementing or are currently implementing as well. For collecting data, like I talked about before, we will be using the Weather API and the DynamoDB tables that we have previously collected. Won't be able to show much information due to privacy concerns and such. Now we will be using a artificial intelligence supervised learning algorithm to be able to plan these flights. Since the flights aren't sequential, i.e. that we won't need to make real-time decisions, we will be implementing linear regression algorithm. Further discussion will be needed to be able to implement random forest algorithm or even an artificial neural network algorithm, but that's all depending on what's the best performance of the flight paths and if it's going to be too complex to implement. This also comes with the requirements needed to meet FAA standards and allow us to be able to have flights be accepted. Next, we need model evaluation, metric being mean absolute error or R squared. And the validation techniques is going to be k-fold cross techniques. And flight pathing, we're most likely going to be using A-star algorithms to be able to flight path, as it's fairly simple, and if there is a flight path that we're able to take, it is able to give us the fastest output. And like I said, this is a high-level overview, and the fine details haven't been fully fleshed out since it's still in current development, and we are excited to continue to be able to develop this. I pass it on to the next person.
So adding a flight in our application is very simple. The first thing you're going to want to do is go to this big button on the left-hand side over here where it says Add Flight. What this will do is bring up a pop-up menu that allows you to input your drone that you're using. This will take from the section of drones that you have already added into your profile. So you'll pick from that. Then you will pick the date of your flight and then the altitude at which you will be flying at. There'll be some other information once we get this part integrated with the FAA API that you will be able to pick your airspace and other information like that. But for now, this is just a preliminary stage showing how this process will work. So once you do that, you will submit your flight and it will populate into this your queue right here. So another option you have as of right now is how to sort your flight plans. You could sort them by date, or you can also sort them by aircraft type. If you have multiple drones, you can sort them by those. So
These are the results of the profile page. At any time, the user can update their information, and that information will be saved in the database. The user will see a successful message after clicking the Save Changes button. Now I'll demonstrate how the profile page works. So let's say we want to change the name to Alexis, from Alexis to Johnny. And the last name from Waldo to Wilbert. And let's say we want to change the password too. So when I click Save Changes, it will display the information updated message. Now, if I click back in the text box again, the message will disappear. If I refresh the page, the information that they just put in is still in their profile page.
This is our application's homepage. Here, users can see a dashboard with their location and an overview of the map, which has not been implemented yet. On the left nav bar, they can access key features like viewing flight plans, registered aircraft, their profile, and changing their settings. They can also access the help and contact pages, as well as log out from the application on the homepage. They can check their notifications in the top right corner, which also displays the user that is logged in. Next, let's move on to the login page. The login page prompts the user to enter their username and password. Once logged in, users can access their account information and take advantage of all the features our UTM tool has to offer. Next, I'd like to highlight our app's settings page. Here, users can manage their account preferences, including editing their role between user or admin, as well as deleting their account. Throughout the course of this project, we learned a number of valuable lessons that helped us achieve success. I'd like to share some of these lessons with you now. First, effective collaboration and communication was very important to us. We overcame obstacles by maintaining open lines of communications, such as having a Discord group chat, and using collaborative tools like Google Workspace and GitHub, as well as holding regular team meetings. Through this, we were able to stay on track and make steady progress towards our goals. Another lesson we learned was the importance of domain knowledge. We had to dedicate a substantial amount of time researching UTM and UAS regulations and standards, such as LANCE, a program for pilots to receive airspace authorization, and Articopter, a program for controlling multi-rotor UAVs or drones. We found this to be essential for developing a tool that met our sponsors' needs. Project management was also a key area of learning for us. By following the Scrum framework, we were able to be flexible with our goals and make efficient progress. We broke the project down into sprints, which made it really easy to identify our next steps and reflect on our work, and it also gave us the room to make changes whenever necessary. Finally, we experienced a lot of professional growth through this capstone project. This project forced us to strengthen our teamwork and communication skills since we had to work with each other, our sponsor, and our instructors. We also got to experience real-world situations where we had to utilize our problem-solving abilities. But we believe that the skills we learned will be very valuable assets as we move forward in our careers.
Getting into the value created by this project, UAVs, or unmanned aerial vehicles, are in the preliminary stages of their usage in industry. Based off a study done by Randy Research, they're projecting a 39% compound annual growth rate of UAVs in the commercial marketplace alone. With this growth, there needs to be a safe and easy way to regulate the flight paths and usage of these drones. To do this, we are creating a user interface that is simple and easy to navigate. This should free up time for human operators to focus on more important tasks in their industry. Our project also aims to provide an application that will provide accurate flight information in these low-altitude airspaces that will reduce in-air collisions and make sure that all regulatory requirements and restrictions are being met. With all of this, we hope to help with the growth of the UAV marketplace by creating a better opportunity for these industries in agriculture, inspection, and last mile delivery and many more. So they're able to have access to an application that makes running their business as simple as it can be. So for future development plans, as of right now, we have a simple outline of our project on how we are going to accomplish that. Going into next semester, we hope to work towards integrating our application with the FAA API. What this is it allows us to approve or deny actual flight plans in real time with the FAA. Along with this, we hope to create efficiency metrics that will deconflict flight paths and be able to analyze other flight plans and adjust new ones to accommodate that data. So through all this, we should be able to create an automated approval system that will safely guide UAVs in low altitude airspaces.